In the last two videos, we calculated the linear equation of the tangent to a curve at some point, and then we used that linear estimate in order to estimate the value of the function, the curve, at some point that we didn't know the y value for. And in this video, what we're going to do is we're going to analyze that estimate and figure out if it's too high or too low compared to the actual value. So let's sketch out this example of the square root of x a little bit. And I did this in GeoGebra in the last video, but I want to really... So the graph of y equals the square root of x maybe looks something like that. I'm going to really accentuate the differences here. All right, and so here is the point where they are tangent to each other, which was 4, 2. And what we were doing is we were estimating at 4.1. And so this is f of 4.1, which we didn't know. And calculating the square root of 4.1 would be a hard thing to do without a calculator. But this is 4.1 comma 2.025, which we figured out in the last problem. All right, so what we can do, looking at this graph that we kind of came up with right here, is that this estimate is higher than the actual value of the square root of 4.1. This is, let me write this way, this is 4.1 comma the square root of 4.1. So the estimate that we came up with, we can tell that it's higher than the square root of 4.1. Because I just happen to know that the graph of the square root of x is concave down at this point. Okay, and because it's concave down, it's going to twist like this, and so the value that I'm looking at is going to be below the line at this point. All right, we'd have a different situation if we were using a function that was concave up. All right, so if this was our tangent point and the function was concave up like this, then this is the point we would be trying to estimate. This is the point that the tangent would tell us that it was about, and our linear estimate would be an underestimate. All right, so concave up is equal to underestimate, and concave down is equal to overestimate. All right, this was really handy for us because I just happened to know this about the square root of x, that it's concave down. But let's figure out how we would figure out if this was concave down just by doing some calculus. So what we need to do to determine if something is concave up or concave down is we need to know its second derivative. So I will turn this into 1/2 times x to the negative 1/2 power, just to do that. So we can calculate the second derivative of x. We're just using the power rule again. So that's negative 1/4 times x to the negative 3/2 power. So what we can see here is that this is going to be a positive number for any value of x. All right, so x to the negative 3/2 power is just 1 over the square root of x cubed. So if x is positive, x cubed is going to be positive, the square root of x cubed is going to be positive, and 1 over the square root of x cubed is going to be positive. And so multiplying that times negative 1/4, so the second derivative is always going to be negative. Yes, which is greater than 0. I'm sorry, that's less than 0. So that tells me, even without knowing the graph of the square root of x, I could tell that this function, the function of f of x, is going to be concave down everywhere. And since it's concave down, I know that any linear estimate I come up with is going to be an overestimate. All right. So this is a question that comes up often enough that maybe you want to memorize the concave up functions are always underestimates and concave down functions are always overestimates. Um, or the other way you can do it is just to remember that you can just draw a graph of the function and the tangent line, just like I did there. Honestly, that's how I remember if of tangent estimates are overestimates or underestimates, just by drawing that picture of a curve with the right concavity and then a linear function, and then I can see from there whether my estimate is going to be high or low. But it's something that will come up a lot. So when you're asked something like that, just calculate the second derivative and figure out if it's positive or negative at the x value that you're interested in.